Parachutes. Does size matter? In the sport of skydiving, one jumps out of a plane from a very large height, roams through the sky, and eventually has to release a parachute in order to make a safe landing. The way a parachute is designed helps the skydiver reach land at a safe speed. So how does a parachute actually work? When a skydiver is falling through the sky, the force of gravity is pulling he or she towards the earth at a very high speed. Parachutes take advantage of a force that is opposite of gravity, known as air resistance or drag force. Once the parachute is launched, it quickly rises up in an upward motion as it unfolds and traps the air molecules within it, causing the air resistance to increase and therefore slowing down the skydiver effectively. As the diver slowly falls, the push and pull forces of gravity and air resistance become nearly balanced, allowing them to fall safely. But the question now is, does the size of a parachute affect the speed of a skydiver? So, I conducted an experiment to see whether the size of a parachute affects the speed at which a skydiver falls. The purpose of this experiment was not to see which parachute was more efficient, but rather which one was able to reach land at the slowest rate to ensure the safety of the divers. My prediction is that the larger parachute would be more effective as it has more room for air particles to be trapped in order to increase the air resistance. Materials that were used during this experiment consisted of one large parachute and one small homemade parachute. We have two different sizes of parachutes, which we will throw from the second story of a building. The surface area of the larger parachute is 1,520 centimeters squared, and the area of the smaller one is 314 centimeters squared. Both these parachutes were the same design and lightweight. Whichever one falls last from when it was released to when it landed on the ground is the most effective parachute. Now let's move on and see the results.
Yes.
So, the smaller parachute landed in 1.21 seconds, while the larger one landed in 2.19 seconds. The larger parachute's speed was 0.98 seconds slower. If the height that the parachutes were dropped from was greater, the results would have been far more surprising. Although my results demonstrate that a larger parachute is more effective, some variables and control factors could include of the wind, or that the parachutes weren't made of the same materials, which could have altered the final performance. In conclusion, the size of a parachute does indeed affect the rate at which one is falling. The reason behind this theory is that larger parachutes allow it to displace more air, causing it to fall more slowly as there is more drag force. Thus, the larger the parachute, the greater the drag force.